Good morning, class, and welcome to this lesson on Newton's universal law of gravitation. Today, we will be able to determine the gravity of other planets relative to planet Earth when given their dimensions. So, this lesson is going to be conceptual, but it's going to be conceptual and mathematical at the same time. So, I guess let me just show you what's going on, and we'll figure it out from there, okay? So we have a 10 kilogram object on Earth. We know that weight is going to be about 100 newtons. So Newton's law of gravitation says F equals G m1 m2 over d squared. Okay? So on Earth, we have this object, this 100 Newton object equals G m1 m2 over d squared. This 100 newtons comes from the universal constant g times its mass, 10 kilograms, times Earth's mass, times the distance between its center and Earth's center. So you can get a lot of questions like this, and AP really likes these kind of questions. So what if we were on a different planet? We'll call it planet A. We're on planet A. And planet A is 2 times the mass of Earth. Everything else is the same radius, so it's much more dense, and it's 2 times the mass of Earth. So, what do? We have our equation. F equals G. I'm going to put 2 me times the mass of the object over d squared. You notice the only thing that changed is that 2 right there. 2 times the mass of Earth. 2 times the mass of Earth. And so if we treat this like a coefficient, we can just pull it out. 2g mass of Earth times m over d squared. Notice this is the same as this, right? So if this planet is 2 times the mass of Earth, and this whole equation here is the mass of Earth, then really the answer is going to be 2 times 100 newtons, because our object is 100 newtons. This right here equals 100. 2 times 100 is equal to 200 newtons. So, once again, you can see how that's kind of mathematical and kind of conceptual. Really, all we're trying to get you to do is be able to understand what this equation is really saying. And I want you to notice this, that, I'm going to go to the next page here, that when it comes to this equation, F equals G m1 m2 over d squared, notice, if we treat this like a fraction, the force and the masses are both in the numerator. They are both in the numerator. And because they are both in the numerator and on different sides of the equation, force is directly related, also known as directly proportional. And we draw a proportion sign like this. It's like an infinity sign, but without the tail end there, so we kind of cross that off. So force is directly proportional to mass. So force is directly proportional to mass. So if that means if mass goes up, force goes up. And you can see from the last page, because mass doubled right here, force went up. Mass went up by 2, force went up by 2. Mass went up, force went up, because they are directly related. So let's take a look at a different planet now. We'll call it planet B. And planet B has 2 times the radius of Earth. So we have F equals G m1 m2 over 2RE squared. So G m1 m2 over 4RE, and that's still squared. So once again, if we factor out this 4 like it's a coefficient, we get 1/4 g m1 m2 over re squared. So when the radius went up by 2, the force went down by 4. So if this was once again equal to 100, 1/4 of 100 newtons, that would be 25 newtons. So let's take a look at this again. Radius went up, force went down. Radius went up, force went down. So this is called an inverse relationship. An inverse relationship, or inversely proportional. We'll go to the next page. So once again, force is proportional to 1 over r squared. We see it in the equation here, g m1 m2 over r squared. Force is in the numerator, radius is in the denominator, so these are inversely related. That means when force goes up, radius goes down. And however, these are inversely related, but notice that it's r squared. So this is called an inverse square. That means if radius goes up by 2, force goes down by 4. They are inverse. One goes up, one goes down, one goes up by 2, one goes down by 4, because 4 is the same thing as 2 squared. So if radius went up by 3, force would go down by 9. Inversely related, and 9 is the same thing as 3 squared. If radius went up by 10, force would go down by 100, because that's 10 squared. Okay? So inverse squares. So let's take a look at another planet here. We have planet C. Planet C has, Planet C has 3 times the mass of Earth and 4 times the radius. So F equals G. Oops, sorry about that. F equals 3 So we factor this out. We pull the 3 out. G m e over or times m. 4 squared, 16. R squared. So if we were on this planet, it would be 3/16 of 100 newtons. I'm not sure what that comes out to be. It's 300 divided by 16. I'm not going to do that in my head right now. Actually, I have a calculator right here. 300 divided by 16. So that's going to equal 18.75 newtons. Okay, let's do one more. Planet D. We're on planet D now. And this planet has 3 times the mass. However, it has 1/3 the radius of Earth. So it's a very, very, very dense planet. So F equals G, 3 me times m over 1/3 radius of Earth squared. So let's factor this stuff out. 3 G me m over radius of Earth squared. And this is going to be 1/9. Now if you notice here that 9 is in a fraction, right? So going back to basic math skills, 3 divided by 1/9 is the same thing as 3 times 9 over 1. We multiply by the reciprocal, so we flip these two. So 3 times 9, so this weight would be 27 times more. So our 100 newtons times 27 equals 2,700 newtons. So that is Newton's universal law of gravitation, basically broken down. So there's one more thing I want you to take from this, is that you can apply these rules to any equation we use. You can apply these rules to any equation we use. For example, simple, F equals ma. What happens if I triple the mass? Well, if acceleration stays the same, then that means my force is going to be 3 times as large. Because these are directly related. These are directly related. So that's just a different way of looking at equations. We're going to see this a lot more as we go throughout the course. These examples of, if you double this, what happens? If you triple this, what happens? If you cut it down to 1/5, what happens? So be ready, that's coming. And that's it.